So welcome back, everyone. Following the previous introduction of GPT-4 Omni and Gemini 1.5 Pro in the previous videos, and considering that usually GPT is considered, let's say, the king, we have decided to challenge them and make a comparison. We have gathered some materials such as videos and pictures, graph and tables, various documents, to see how they're able to process them and what's not feasible. I will be the one representing GPT. Peter will be the one standing for Gemini. So who do you expect to win?
It's going to be a close call. I'm pretty sure about that. But I think also what is really interesting from an industrial perspective, from an industry perspective, is how they relate, what they do better and how's the quality. And I do think there are some differences in features as well. So let's see. I'm curious to find out.
Then let's start with something very simple. Can you upload an image? I'll do the same.
Sure. I have this image, which I show you just quickly. It's basically a spindle and two spindles. One is damaged, obviously, and the other one not. And I just ask it, what do you see? And so the impressive thing about the models is actually that the classical AI, they had to be trained by lots and lots of pictures to identify anything. And they just know it's a spindle. So that's already pretty good. It says, well, also that it's damaged, visible and wear and tear. And the interesting thing from an industrial perspective is you can use these algorithms already and then apply that to certain instances for safety, for predictive maintenance and else. The right photo is new or repaired. So that looks good. It says it's replacing a damaged spindle. So I'm pretty happy with the result, actually. What did you got? Perfect.
Now I will share my screen and show you. So I was typing in the question already, and it says, depicting two different states of the same spindle or axle shaft. The image on the left shows a spindle with significant wear and damage at the end, of course. The other one, spindle has been repaired or replaced. Then I would say he understood what he's looking at. Impressive, quite good, very nice. Now, what's next? Let's move on to tables and graph.
Exactly. So I'll take back over again.
Yes.
And what I would like to show is now a table here, this one.
Mm-hmm.
And basically it shows products with some energy consumption. And what will be challenging to ask it, and I already asked it, which product used most energy. So I upload that screenshot and let's see if the model can provide me based on some dashboards. I mean, that is interesting from an industry perspective. If you just have some dashboards and in that context, it can already guide you. But based on this chart provided, product 2 used most energy and it got the answer pretty quickly. So I have my doubts, actually.
I know it's wrong. I know the solution. I know it's wrong. I'm going to show you mine.
Okay.
So it says, because I was already asking which is the most and least energy consuming product, it says that product 3 is the most energy consuming and product 5 the least energy consuming. So he's right about product 3, but wrong about product 5.
So just to show you, basically, I asked it based on this chart again. And what came out was that he tried to calculate actually, well, the amount for energy consumption. But is that result correct?
No.
It's not. So that's why I also provided the CSV file, which looks like that. Yeah, so it's basically a chart with lots of numbers. What I tried before actually was to ask for one specific field, and it got it right. That's, I think, already amazing. You can ask what's the energy consumption for the relative energy consumption of product 2 on the 3rd of June, and it gets it right. So that's pretty clear. But now let's see if it gets the analysis correct. How is it this time based on the table?
Now it's correct. It's correct.
Now it's good. Perfect. So, well, obviously, I mean, this was very difficult. I couldn't see the difference in the chart, but based on the numbers provided, the models get it right. What's next?
So if you work on machine data, definitely works. It works. If it works on images, still not that precise, but it's definitely working on it. So now we can see if they're able to process videos. You sent me a link before, a YouTube link. You can also start directly from yours, and I'll try with GPT.
Yeah, let's see if that works. Did I have to still? Oh. Maybe you can take over and I'll look for my link first again.
Okay. Let's see what's the answer. Not able to do that.
No, mine neither. Mine neither, but let's try something, because what is in the video actually? We tried now a video without text, and that seems to not work. However, let's see if, for example, this one would be a video I recently did in the Manufacturing X setup, and let's see if it can do this one. So I uploaded it today, and basically what we talked about in the video was the combination of servitization and artificial intelligence. So this would be what I expect now to come out. And indeed, it can really take out the key points from the video. It talks about the digital transformation, servitization, artificial intelligence, some recommendations.
Share your screen and let us know.
So and indeed, it could use the content of the video, and it talked about digital transformation, servitization, artificial intelligence. Perfect. So that was a very nice summary of what we did and what we talked about at the Machine Builder X presentation.
Definitely. Now, last challenge. So I'm pretty sure that GPT algorithms are quite good at it, because we use the same algorithms for Wilson to process documents. But I downloaded a manual from the Baume website, public document, and I've seen a diagram, and I want to ask GPT if it's able to provide a description of it.
Which page was it, or how did you call the diagram?
It was at page 7. And it's a, let me check, block diagram software.
I'm curious it can do that. So maybe I can also open that people see what it is about.
Mm-hmm.
That's basically this block diagram, which we asked it for. And now let's see how fast they can analyze it. So it very nicely describes the different aspects.
I'm doing exactly the same.
And quite fast. So I'm impressed by the speed it did that. How is it for you? Do you want to share?
I'll show you. Absolutely. I would say another very precise description. So let's start from the top. Measurement, factory calibration, damping. I've seen the same on yours. I would say that's comparable.
I do have a little bit more context on Gemini, I would claim.
Probably, yes.
And I could also ask it for YouTube videos. So I think it's a very close call, and I think it's very difficult to compare, because you really need to see the details. And there is some hallucination on both ends. So I'm sure it's valid to work together with experts in order to make sure that it's always correct. But I'm quite impressed about the results on both ends. What do you say?
Same here. And I think the most important thing is understanding, first of all, the use case. So maybe there is one algorithm which is applicable to one and another algorithm to another case. So let's focus on the main goal and then select the right algorithm.
That's actually absolutely true. We talked last time about different versions of Google Gemini, and I think it will be a mixture of different algorithms and models.
Right, that's all for today. See you next time.
Bye-bye.